All right, hello. What is up, everyone? Not sure how many people are here yet, but what's up? Hope you're all having a good day. My name is Izan. I'm a smart contract engineer here at TFL, and I'm joined by two of the GOATs, if they want to introduce themselves.
Hello, everybody. Great to be here. I am Saad Najafi, aka Mo. I am a core engineer at Terraform Labs, Korea. Great.
Yep, and I am Carlos Santiago. I'm also a core engineer and currently working in Mirror, Anchor, and other cool projects. So let's get started.
All right. Okay, so this is going to be a wonderful yet brief technical overview at Terra, where we will discuss. First of all, welcome everyone from the hackathon. I just wanted to say thanks for being here, and I hope you all build something that's super kick-ass. Okay, so today's plan, what are we going to talk about? Well, we're going to skip the basic smart contract stuff since you can all find that at academy.terra.money. Thank you, Terabytes. That's an awesome workshop. Then we're going to talk about some Columbus 5 versions that you need to get ready for, testnets, how to use the blockchain states from JavaScript, Terra.js, a live demo of a quick bot, and some sweet architecture sessions and demos from Carlos and Mo as well. So jumping right in. So Columbus 5, as most of you might know, is a big mainnet upgrade that we have. The important things for you developers is that you need to target two specific versions, and that is CosmWasm Standard 0.16 and CosmWasm Plus 0.8. So make sure that you're building in those two versions just so that it's compatible with the upgrade. And also, if you're using Terra.js, make sure to use version 2.04 and above. We have three main testnets here on the Terra blockchain for you to test your code on. The first is local Terra. And now local Terra is basically a fresh blockchain state that is local on your computer. So there's no other contracts deployed except for what you put on there. So it's great for testing initially. And then we have two testnets. There's the Bombay testnet and the Tequila testnet, which have all the mirror and anchor contracts on them and all the others that would exist on a real mainnet. Bombay is specifically for Columbus 5 version CosmWasm, and Tequila is for Columbus 4.
Oh, yeah, I think it's also nice to mention that Bombay 10 was built from Tequila 4. So if you previously had your test contracts on Tequila 4, now you can rehearse the migration from Columbus 4 to Columbus 5 by doing a code migration on Bombay 10. So yeah, just a quick little detail.
Yeah, good point. Okay, so LCD, FCD, Mantle, and Terra.js. These are some of the developer tools that we provide to make working on Terra easier. So LCD is an HTTP provider that basically gives you access to the entire blockchain's current state. And it's connected to our RPC, and these are the two endpoints for LCD, Tequila, and Bombay probably has the same thing, just replace Tequila here. And we'll look into how to use these later. Then FCD is basically an aggregator of the states and the details that are in LCD. It allows you to do aggregated queries like, what are all the transactions for this account? List all the validators for XYZ. Then Mantle is a custom-built GraphQL endpoint that we've made. And it's just a lightning-fast version of LCD, basically. And GraphQL is awesome, so it can make a lot of developing on front end much easier. And finally, we have a Terra.js package, which is just an NPM package that allows you to do everything on the blockchain, from querying to executing. It's honestly surprising how much cool shit you can build without even needing to create a smart contract. All you need to have is access to Terra.js, and you can build some awesome front ends that interact with the chain. So now that you know what we have, let's dive into a quick demo where we'll build the beginnings of a little arbitrage tool. And hopefully this will provide you some insight from how to actually use Terra.js and the other dev tools that we have. All right, live coding, always a little sus. Okay, so I've got this terminal pulled up here, right, inside a little folder. Obviously, we'll start with npm init. Boom, 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 rip through all of those. And then we will create our index.js file. By the way, it's recommended that when using Terra.js, you should probably use TypeScript, but we're just going to, oh, I don't know if you can see this. Can we get a little zoom on this, perhaps?
Maybe you can increase the font size.
Oh, nice. Command plus.
Right.
Oh, that's better. Can you see that?
Yes,
You see
yes.
that? Okay, cool. All right, usually code dot just works, but I guess it is not. So we will rip open Visual Studio. Desktop Terra demo. Cool. Okay, so what do we need to do now? First, we need to install Terra.js as per usual. So we will rip npm -i Terra.js, npm install Terra.js. There we go. So simple as that. Now you have access to basically everything on the blockchain. And we will also install node fetch. And that's just going to allow us to, fetch stuff. Okay, so we are going to first, so we want to create an arbitrage pool project. And what that means is we're going to create a little bot that kind of swaps between pools. So as most of you know, on Mirror, there is multiple different pools for M assets. So what we're going to do is we're going to create a bot that looks at the 3 different main pools that I want to look at, which are the UST METH pool. Hopefully you guys can see this. The UST METH pool, the METH BETH pool, and the UST BETH pool. And the reason we're going to look at these is because occasionally from time to time, since these are all AMMs, the price between METH UST and BETH UST, which should ideally be constant, are off from each other. And then since we also have an METH BETH pool that can swap from one to the other, occasionally that is also a little off. And what happens then is we have arbitrage opportunities where we can swap, for example, from UST to METH, METH to BETH, and then BETH back to UST and make a profit. And we can also do that in reverse. So our bot is going to basically look at these prices and see if there's an opportunity that we can take advantage of. So right here is one of the TerraSwap GraphQL endpoints powered by Mantle. And that just allows us to run quick queries like this, right? Where we are querying this pair address, right? Which is the UST METH pair address. and getting stuff like which tokens are in there, the token addresses, the price of METH was last at. Here is the price BETH was last at. And then we also have, the conversion from METH is equal to 1.02 BETH right now. And 1 BETH is equal to 0.97 METH right now. So as you can see, there's a discrepancy here because ideally it should be 1-to-1. And that means there's most likely some sort of arbitrage opportunity that we can look for. Important thing is, how do you get access or find these pair addresses? Well, you can go to terra.mirror.finance/tool and you can pick your pool. So we are going to pick the ETH pool, for example, and you can copy and paste the address from right here.
Yeah, I wanted to say that I think that not a lot of people know about this tool, but it's very cool and can be very helpful. So there you go. Yeah. Now it's made it public.
I actually just learned about it recently as well, and it's super handy.
Yeah, it's super handy. Yeah.
So before this, I found out the addresses that I need. So we are just going to paste these in here. Boom. Okay, so now that we have all the addresses of what we want inside this little map that I've built, so here's the METH address, the pair addresses for these pools. Next, we need to create an LCD client. And what that means is it's basically an object from Terra.js right here that will allow us to send transactions to the chain. So const Terra equals new LCD client, which takes in a config, and the config first has the URL of the chain that we're trying to reach, the LCD. So we're going to use mainnet here to get their real prices. So terra.dev. Then we have to specify the chain ID. By the way, all these details are going to be on the npm Terra.js documentation online. So if you miss something or forget something, you can always go there and get a quick guide. Sweet. And then we want to specify the gas prices. So something that's kind of important that we saw recently is we increased the price of gas. And because of that, a lot of people's bots that they had made started failing because people hard coded the gas prices. So something that you should never do is hard code the gas prices because from time to time they will change. So we can fetch the gas prices right from here. And we can see what they look like. We have a custom endpoint to do that, which is quite handy. Right, node. Uh-oh. Uh-oh. Okay, we got to specify this as a module. All right, let's see if this works now. Nice. Okay, so these are all the gas prices, as you can see here. So we are just going to use UUSD, which is UST, micro USD, basically. So we can specify that in here by doing gas prices. Sweet. And then, all right, now we have our LCD clients. Next, we want to make a wallet for ourselves. What's really cool about Terra.js is that you can just spin up a wallet in 2 lines of code. So how we do that is first we create a mnemonic like this, and then we just go say wallet equals our LCD client dot wallet, provide the mnemonic key, and boom, now we have a new wallet. And we can even check out the address of that wallet by running this. Boom, that's our new wallet address. Okay, so next, let us write a function that shows you how to send a transaction on the blockchain. So we're going to do async function, and it's async because the transaction has to go through. Send transaction, and we will provide a LCD, a wallet, and the messages that we want to send. And we are going to return a promise. All right, since our time is limited, I'm just going to copy and paste the one that I have, and I won't walk through it. So here what we do is we take the wallet, we sign our messages, and then we literally just write wallet.our LCD client, transactions, and broadcast them to the blockchain. And then we can console.log the result, and that's it. Super simple. So next, what we want to do is let us query the prices of METH and BETH so that we can see if there are arbitrage opportunities. Something that's important to note, whenever you're sending money or coins or providing a dollar value to Terra, you're always specifying in micro amounts. So that means 10 to the minus 6. So for example, if you want to swap $100 or 100 UST, you need to actually say, when you provide the amount, that it is 100 times 10 to the 6, basically. So we can say so we're going to create a coins object, which basically means what coins you're sending, what you have in your wallet. Boom. Specify the type, and then we're going to do swap amount times 1, 2, 3, 4, 5, 6. Boom. And turn it into a string. All right. So now let us look at how we actually simulate the price of METH here if we were to swap $100 to METH. So let's create a simulation of UST to METH, terra.wasm.contract query. So what this function allows for is you can just put in a contract that you're trying to query and provide a query message. But sometimes it's confusing on what the query messages should actually look like. And to figure that out, occasionally you have to actually look into the contract details. So for TerraSwap, for example, which we're looking at here, if we go to the TerraSwap pair address or contract on the GitHub repo, which is totally public, you can see that the query message to do a simulation takes in, it's called simulation, and it takes in an offer asset, which is of type asset. So then we figure out, hey, asset is in the asset crate. So we go back out to here, find asset.rs. An asset has an info and an amount. What is type asset info? Well, we look for it, and we see asset info is an enum that's either a token or native token. So a token refers to any CW20 token like Mir, Ankh, things like that. And native tokens are basically Terra stablecoins like UST, KRT, or Luna. So let's now create this query to figure this out. So we are simply going to query UST and ETH pair that we talked about earlier. And we are going to use that query message of simulate that we just described. Boom. Smack that on. So if you remember, it was simulation. There's an offer asset. Here now we have to provide the asset info. And it was a native token since we're sending UST. And the denom is USD. Boom. Okay, so now if we just console.log this simulation, we should be able to get the price. Nice. All right, we're failing. Okay, let's see why. Okay, this was all fine. This was all fine. Let's make sure our LCD is
Maybe
good.
you are missing the amount.
You're totally right. We are missing the amount. Did it specify that here?
Oh,
You're right. So amount, remember we're going to take the swap amount, multiply that by 1, 2, 3, 4, 5, 6 of these, turn it into a string. This is super bad, by the way. Make sure you do it nicer than this, but we're just trying to get the job done. Invalid index of 1. Ruh-roh. All right, let's see.
oh, the amount should go inside the offer asset, I think, if I remember correctly.
Yep. Yep. I should always refer back to the query message, what it actually looks like. Thank you, Carlos. Okay, sick.
You're welcome.
F. Press F. Okay, let's see. I don't know what's different here. This looks exactly the same. Okay, it seems I have this poorly formatted, but this is the right way to format it now. And now, as you can see, when we run, we get that if we swapped $100, we would get the return amount of 31152 micro METH, which is actually equal to what? Return amount divided by 1, 2, 3, 4, 5, 6. Boom, 0.03. So that's how much you would get. So now if you actually want to make this swap with this wallet that you had just created, you'd basically just create a message that looks very similar to this, that you can find how it's formatted by looking at the contract on TerraSwap's GitHub. And then you would just pass it to our send transaction function and you would make that swap. Since we don't have time to run through the rest of the arbitrage routine, what we would end up doing though, essentially, is that we would create this simulation to see how much METH we would get. Then we would do a similar thing where we take the return amount of METH, swap that to BETH using our METH BETH pair, and it would look very similar to this query. And then we would swap that return to BETH amount to UST. And we basically see, okay, if we do all three of these swaps, do we get more than $100? And if so, then we take those messages and we just put them in our send transaction function and we actually make those swaps. So Terra.js is a very powerful tool that is actually pretty easy to use. So yeah, that is basically it from me. I can maybe put up the little naive bot that I made later. If other people want to see it, just let us know in the comments if you want that. And now I will pass it off to Carlos.
Before moving to Carlos, it's worth mentioning that instead of having Bombay for testing migration of tequila to Bombay, we provide a testing environment with local Terra that it's currently in the local Terra repository on GitHub. Uh, Check out the branch code migration, and there is a guideline there you can follow to test the migration of the code in smart contract locally, because we have only one chance of migration. It's better to do it this way. It's highly recommended. Yeah, pass to you,
Yeah.
Carlos.
That's a very, very useful tool these days, since I guess everyone building on Terra is preparing for the big moment, which is the migration for Columbus 5. And yeah, so as Izan said, like a Terra.js is basically 80% of what you need to build with Terra. You can do fantastic stuff like, bots, data collectors, integrate your frontends. So yeah, and now we will talk a little bit more on the contract side. So if Izan can show again the presentation, I will start talking a little bit about Mirror. So yeah, I will try to do a technical overview of what is Mirror and how it's actually built. So to put it in simple terms, Mirror is just like a bunch of smart contracts that do this basic thing. Um, Mirror contracts want to mint CW20 tokens, which are the M assets like MAPL and BTC, when users lock a certain amount of collateral determined by a collateral ratio and asset price. These collaterals can be UST, Luna, ANC, or AUST, and MIR, and also other M assets. And other than that, the protocol tries to incentivize users to keep those M assets at a desired price, which is the price from the real world. And yeah, those are the two main things. And then, of course, some other cool things. And with this, what Mirror achieves is offering a set of CW20 tokens that track the price of real world assets like stocks, ETFs, or cryptos, which sounds simple, but it's actually very powerful and allows for also very cool integrations. So if we go to the next slide, maybe what I want to emphasize with my part of the presentation is that anyone can build their own Mirror protocol, or what's even better, integrate Mirror with your own cool ideas. And because we want to have people do these cool integrations, I will try now to explain a little bit how Mirror is actually built. So I will share my screen first, and I will show this diagram, which explains a little bit how Mirror actually works. I think that we have not really done this before, and yeah, I think it can be very helpful for people that wants to build something with Mirror to know a little bit about how Mirror is actually built. And I think that it can also give people ideas to about like how to architecture your own decentralized application on Terra. So yeah, I want to give ideas about for example, when you should separate certain functionality into different contracts, or how to organize those contract interactions. So I'll try to not go very deep, but just explain a little bit of what is the purpose of each of the contracts that we have in Mirror Protocol, and a little bit of the interactions between them. So if we start by the top contract, if I can move, which I don't know how. Okay, yeah. So we have the governance contracts. You may be familiar with governance. Is the place where you can go and stake your MIR tokens and also create and vote on polls. So the Mirror is a fully decentralized protocol, which means that MIR holders are the ones that decide what happens with the protocol. And that's why you see that governance actually owns all of the contracts. When a contract owns another contract, it means that it can modify its parameters and it can do special authorized operations. So yeah, governance contracts is where you go to stake and do everything related to polls. As you may know, like users can decide to whitelist a new M asset or to change any of the protocol parameters, such as protocol fee, for example. Then we go to another very important contract, which is factory. So Mirror, what basically does is manage a bunch of M assets, right? So what Factory does is it holds all the logic that goes into creating a new M asset. So yeah, basically when users want to whitelist a new M asset, it will be an operation that goes into Factory, submitting the needed parameters, such as like the name, or the price feeder, and Factory contract will do the necessary operations, which is basically instantiate the CW20 contracts on Terra that you can see here, and also register the new CW20 token on Mint contract, Oracle, and staking contract. So it will do all of those initial tasks, to basically set up the DM asset. Following that, another very important part of Mirror is the Oracle. So M assets mirror or like reflect assets of the real world. Since we don't have any on-chain price source for that, something external needs to provide those prices. And we do this by having off-chain feeders. So for example, Apple would have a certain price feeder assigned that would periodically query the Apple stock price from different sources and then feed it into the chain. We have different price sources. Also, some of them come from other on-chain sources, such as Band Protocol. So yeah, and so if we have the price feed, then we can go to the Mint contract, which is basically the heart of Mirror protocol. It manages the M asset borrow positions, which basically allows to mint, burn, deposit, mint, burn M assets, and deposit, withdraw collateral. So as you know, you can create borrow positions with for different assets and different collaterals. How Mint contract does this is basically getting the Oracle price for that M asset, then getting the collateral price from the collateral Oracle, and using the design collateral ratio, it will allow a certain amount of M asset to be minted. As you may know, if in the future that price for the asset goes higher or a collateral price goes down, the position might become vulnerable and you might get liquidated. So all of that is managed by Mint contract. So actually, when you want to do integrations with Mirror, most of the interactions that you need to do is with Mint to do these basic operations, and also with Oracle in case you need the M asset price. So as I said, M asset prices come from here, which are fed by external sources. And the collateral prices come from a different contract, which is the collateral oracle. And this one gets the collateral prices from Oracle or from other sources, and or also even from TerraSwap pairs. This collateral oracle also has different operations to, for example, change the collateral ratio for a certain collateral, or to, for example, revoke collateral in case, for example, we don't want AUST anymore as a collateral. Users can create a poll to revoke it from the collateral oracle, and then no more borrow positions with AUST as collaterals will be allowed. So I think those are the main contracts, and then we have others that that basically provide additional functionality. For example, community, there is a pool of MIR that is there and can be used to fund different projects that want to integrate with Mirror. Actually, if someone in the hackathon wants to build a cool project with Mirror, you can submit a governance poll to spend a part of the community pool and get some funding for that. So yeah, that's something to take into account. And then we have a staking contract, of course, as you know, so you can get rewards for providing liquidity for different M assets. So basically, Factory, when it registers a new M asset, it will also register the design M asset pair in the staking contract. And Factory will periodically put rewards to staking contract here based on a distribution schedule. And yeah, basically, if you bond your LP tokens here, you will get a certain amount of rewards. Also, a portion of those rewards go to people that do shorting. So as you know, there are like LP tokens and also short tokens. So how these rewards deposited by Factory into staking are split between like short rewards or normal LP rewards are calculated by this contract here. And I think this is a great example of when to separate contracts. So in this case, we have a contract called short reward, which only basically calculates how big of a portion of rewards we should give to short tokens bonded. So why do we separate it into a different contract? So this is because if in the future we want to change the calculation, which is quite complex, we would only need to change the address of the contract. We don't need to migrate any code in here. We just change the address, and then we would be good to go. This is something that users can do through governance by basically, deploying a new short reward contract and then changing the address on staking. So yeah, I think that's a good example of when it's useful to separate contracts into different ones. Yeah, and I will go over like the other ones very quickly. Collector is where Mint contract deposits some protocol fees and then swaps it to MIR and then gives it to governance contract. So here is how you get your governance rewards, your MIR rewards. Also, lock is a small little contract that deals with the locked UST. When you want to create a short position, as you know, you create a borrow position and then instantly sell the M asset. So the UST that you get from that is given to lock contract, and then it's locked for a certain amount of time. And other than that, then we have limit order that also, I don't think a lot of people know about it, but you can basically submit orders, and third parties can fill orders. So actually, this is writing a limit order bot is a very good first project to do on Terra, and you can get some profit from that. So yeah, following a little bit of, you can do it with with the tools that Izan explained before, and it can be a cool little project to get involved in Terra ecosystem. And yeah, that's basically it. That's how it works. And as you know, the other thing is like a TerraSwap. All the assets are like TerraSwap tokens with their TerraSwap pairs. You can trade them on TerraSwap web app. But yeah, that's basically it. So I hope this presentation or like this introduction made it a little bit easier to understand how Mirror works and gave some ideas about how to integrate with it. And other than this, I want to go back to the presentation, please. Yeah, so before this one. So yeah, want to mention about some tools to integrate with Mirror. So we have Mirror.js, which is a very simple library to generate messages to interact with the contracts. So Izan, when he did the demo, you saw that he had to write the JSON messages for each query and each execute message. Basically, Mirror.js provides that. So instead of having to write the JSON open position, collateral, native, denom, like all of that, you just call mirror.openPosition and put the collateral, the asset, and then you are good to go. So it's something that works with Terra.js, and it makes basically it makes it a little bit easier. So yeah, it's a good tool to have. Then the Mirror protocol Rust crate. So this is in case you want to integrate your smart contract with Mirror smart contracts. This protocol crate, which you can find in crates.io, it provides the data structures to interact with Mirror contracts, which again, it's basically the message formats for all operations and queries on Mirror contracts. And other than that, we also have Mirror API, which is another GraphQL interface that basically gives Mirror-related historical data. You can also test it out in this URL. And basically to do some cool graphics or to do data analysis, that can be very helpful. And I think that's all for me about Mirror. And now I think Mo can talk about Anchor.
Welcome to people who recently joined. So this is Mo. I'm here to talk about Anchor Protocol and to talk about contracts behind Anchor Protocol. So just a brief introduction about Anchor. Anchor is a money marketplace that you could deposit your stablecoin and get yields, and also provide collateral to borrow stablecoin while you are incentivized by ANC token. Behind Anchor protocols, there are three different categories of contracts. The basic one is B assets contract. That is the kind of all other contracts dependent on that. And this is the contracts that we first developed on Anchor. And the second category, which is the hub of the whole Anchor protocol, is money market contracts. And the third category is Anchor token contracts, which we discussed a bit about it with in Mirror. There are similarity between Anchor token contract and Mirror token contracts. So let's start with the Anchor. Let's start with the B assets contract. So just a brief introduction about B assets. B assets are asset derivatives that accrue some reward while it's fungible. So in case of Anchor, so B asset, what we do with B asset is like you provide your Luna, the contract stake it, and issue a B Luna token for you. And in the B asset contracts, we have three different contracts that work together to get it done. The first contract, which is the kind of a hub of everything is the asset hub contract, which receives Luna and issuing B Luna for you. And B Luna hub is the place that we also controls the reward and send them to the reward contract and swap them to USD denomination because of the way that we use it in Portugal. And also, Biluna Hub is the place that you could get back your Luna. So you send your Biluna to the Biluna Hub and request for unbonding, and it will process your requests within 24 days to get your Luna back to you. So this is the whole concept of the assets. We use this structure for BLuna and BEAS too, but we don't have BLuna, a BEAS hub in terms of BEAS. We only have BEAS token and BEAS reward contracts. So when you are issuing a B Luna or BEs, so now you are eligible to borrow from Anchor, which I will explain about it in money market contracts part. So can I have the next? So money market contracts is the heart of the Anchor. So where you can deposit your stable coin and get yields, or provide collateral and borrow stable coin. So in Anchor, in money market contracts, we have 7 different contracts that work with each other to achieve the goal of Anchor. So first, an important one is market contract. Market contract is a place that people can deposit their USD or withdraw their USD back. And when you deposit your USD, you get AUSD based on the exchange rate of the market contract. And you could give the contract AUSD and get back your USD while you're receiving the yield that from the time that you have put your USD. And also from a market contract, you can borrow stable coin, but it depends on other contracts. And you need to provide send messages before sending borrow stable from market contract. So the 2 important contracts that play an important role here is custody and overseer. So custody contract is the place that you send your B asset to that contract and provide collateral. So custody contract from now owns the transferred B asset, so that from that moment of time, that contract will receive the rewards of you. Receive the reward of the B asset that you provided. And also, after you put your money in custody, you need to lock your collateral. So the way that we lock the collateral is using overseer. And overseer is the place that we use the Oracle price to get the amount that people can borrow. So Oracle is another contract here that is kind of a central point that we feed the price of different B assets, that overseer can use it for both liquidation and also for borrowing, to help people to borrow. So um, this is another contract called Oracle. There are a bunch of other contracts here that we use it for ANC emission rate and borrower interest. One of them is distribution model. Distribution model is a place that other contracts can query and get the ANC emission rate for the user. And there is another contract called interest model, is a place that we get the borrower's interest rate. And also, as you know, I think a liquidation is very important part of an anchor. And we have a liquidation contract where we can submit a bid for a collateral and get the loans that's under collateralized. So these are the all money market contracts that that is out there, and the ANC related token contracts are similar to mirror token contracts. One of the important one is Gov. So governance is the place that controls the whole protocol and protocol configuration. So if we need to change anything in any contracts to help it to behave better, we do it through Gov proposal and ask people for vote. And as Carlos mentioned, so each contract has its own configuration. And these configuration is handled by the owner of that contract. So the owner of the contracts on Anchor protocol is the Gov contract. So it's up to ANC holder to decide how the protocol should behave and how the protocol should be. So the governance proposal is the place that controls everything. There is another contract which if you want to vote, you should first work with that contract, which is a staking protocol, a staking contracts. So a staking contracts is where you bond your ANC USD LP token there. And then from that time, you would get the reward. And there is, as we have the same for mirror community contract, which supports the ANC for people who want to integrate with Anchor for granting them. And we also have collector, which is another contract that collects protocol fees and buy back ANC and distribute it to the governance stakers. We also have a distributor contract. Distributor contract is a contract that distributes the amount of reward that people will get because of borrowing, and amount of ANC reward that people will get because of borrowing. And there is another contract which is vesting, which is a time lock contract that we use for getting for locking the vesting token there for 6 to 1 year. These are all contracts behind anchors, beyond Anchor, and I think in the future we are going to introduce more, and it would be great if people could go to our GitHub repository and give us a pull request or review our contracts to see whether we can improve Anchor to help the community. I think I have other slides. Can you help me with that? Yeah, so how to use Anchor? There are two SDKs out there. One of them is Anchor.js that that people can use easily by fabricating message. So message fabricator is there that you could only instantiate a message fabricator and use it easily. And Anchor Earn, which is another SDK that we have, uh, especially for the earning part and earning functionality of Anchor. That it's easy to use. It's super easy. Just create your account and then create Anchor Earn, and you can simply send transaction to the chain. Or if you are a custodian or something, you can use a custom signer or use a custom broadcaster there, which is these two functionalities provided especially for Anchor. That is it for Anchor. I think I can wrap it up here.
Okay. We got about 10 minutes left. So I know you're all here because you want to make some bank and arbitrage. So I'm gonna spend 5 to 10 minutes speed running the last bit of this this arbitrage bot for all of you. Feel free to leave if you want. Actually, let's answer questions first, and then I can do that in the last 5 minutes. So if anyone has any questions that you want us to answer, please just hit the chat now, and then we can try and respond to those. The Crypto Squad, yes, we will try and make all of this downloadable.
Yeah. Oh, I think I saw one about like how the distribution, the reward distribution on Mirror is done. So basically, there is an operation on a factory contract and also on collector that anyone can call at any time. So that operation does the reward distribution. So usually it's some bot that like periodically triggers that operation, which basically swaps protocol fees to MIR and then deposits it to governance. That's for the governance reward. And for the LP reward, there is a operation in factory contract that checks the distribution schedule of factory and then deposits the correct amount of MIR to a staking contract. And then it's distributed to all the MASET LP tokens bonded in there. Yeah.
Something important to note.
Is that
hit it.
Is that the blockchain is a message derivative system, so it must be called by either a contract or either an entity in the chain. So it's either a contract or it's an address. So that's why that's how it should be triggered, any kind of message on the chain.
Yeah, so what he means is like you can't have a contract that's listening to states in the blockchain and just automatically executes itself when something happens. You have to have a bot or something using Terra.js or something querying contracts, and when a situation arises, triggers the messages.
Yeah, it's a message-driven system. It's not automated. It should be triggered by an entity. Yeah.
Any other questions?
And we also have a kind of reward distribution mechanism, which I think it's the same among all the Terra protocols. Is that we use an index to calculate the global index that calculates the current state of the reward, and there is a user index which we calculated based on the user share of the total amount of shares is there. So this is a way that we calculated rewards fairly in TerraChain.
Crypto dude, there's a there's a hackathon going on right now, so you should try and maybe hop on a team there, and you can make a sick front end for one of the projects.
Yeah, and also if there are any contract developers, Rust developers, we would welcome you with open arms, right, Mo? Yeah. So yeah, I think like Terra is looking for talent. So if you're interested in
Yeah,
working with Terra, you
we are
can.
looking for talents. Just if
Exactly.
you think you're competitive enough, then Terra is a good place for you.
Yeah, I just want to reply a quick question by Team B. So he was asking about the limitations of interactions with Terra.js. So I think like in Terra, so we don't really have a limit. It's more like a fair use rule. So I mean, people shouldn't abuse the public endpoints of Terra. But also, I think in the future we will incentivize more people building their own infrastructure, like their own LCD endpoints, their own data collectors, and yeah, and if you want to do something serious and build something strong on Terra, you may look into also building your own data collection system. Then you're running your own node for transaction propagation. And not rely so much on TFL, which everyone seems to be doing. And then when TFL goes down, then everyone rages. So, so yeah, we should decentralize infrastructure for sure. That should be something to take into account.
Jeff, yes, you're right that it is having a bot interact is a centralized endpoint. So bots need to be made well, or you need to have options so that if something does fail, you have a backup that keeps sending the messages if needed.
Something to mention here is that we have two type of messages. One of them is permissionless, and one of them is permission, like what we talk about in update config usually. It's permission messages that only one entity can call, and other messages could be called by anyone. Something like distributing rewards or update global index in terms of anchor. Everybody can call it, so it's not like it's going to be failed if the bot doesn't work.
Yeah, you could have like two bots. Should be fine.
Anybody can call it.
F. So the Anchor website is the app on Anchor website is pretty easy to just deposit your UST into if you have UST in your wallet. But even as a non-technical person, if you want to integrate it or build it into something else, the Anchor.js and Anchor Earn repos that Mo talked about earlier, they basically have a 7-line SDK that lets you create wallets and put funds into Anchor Earn and get that 20% yield extremely easily.
Yeah, exactly. So what we claim in Anchor Earn is that you can interact with the Earn part of Anchor with 7 lines of code. So this is kind of the motto for us.
All right. Is there any more questions? Can you integrate Anchor into our site? Yeah, you could. You could definitely integrate it with the simple UI.
Okay, should we wrap up?
Nice. All right. 2-minute speed run. Here you go. Feel free to leave. Okay, this is where we were last. I don't know how to get this drawn away. All right. This is where we were last. We had simulation UST to METH, right? We figured out, okay, this is the return amount. So remember, we divide by this to get how much we actually get back in non-micro versions. Then what we want to do is just quickly rip another simulation that's going from mETH to bETH. How do we do that? It's very similar to the first one we wrote, right? We just instead are going to query the mETH bETH pair. We're going to do a simulation again with an offer asset, but this time the info is a little bit different. So here, remember, it was a native token, and that's because we were using Terra stablecoins. But now, since we are sending a CW20 token, which is mETH, we switch this to using token, and we provide the token contract address, which is mETH from our map. Remember that we got all this info from the Mirror Tools website. So this will simulate the returned amount we get from mETH into bETH, and then we can see how much bETH we got, and then we take that bETH and we do the exact same thing, but back into UST. So we get the UST bETH pair, rip another simulation, sending bETH to the contract, and this will be our final UST returned. So let's look at this. Boom. Nice. So right now, if you were to send $100, you would first get 0.03 mETH, 0.03 bETH back after that swap. So they're pretty one-to-one right now. And then 99.7 UST returned. So right now, there is no arbitrage opportunity. But what this allows you to do is you can continue running this query every minute or every 30 seconds or every 10 seconds if you wanted. And whenever it's larger than 100, run those transactions to make the actual swap and profit. So there's a lot of opportunities like this across TerraSwap and Terra blockchain. So it's a good side hobby to get started in developing. All right, speed run over. If there's any last questions, answer now. Otherwise, thank you all for coming. It's been a time.
Yeah, thank you so much, guys, and we'll look forward to see your cool ideas on the hackathon. And yeah, and you can always reach out to us on Discord or Telegram, and if you ask any questions, I'm sure there will be someone there to reply ASAP. Yeah, thanks, guys.
Okay, great to be here. Waiting for your pull requests and your great idea everywhere, and we would be there for you.
Yep. Hope you all build some kick-ass.